5 steps of programming. Identify the problem. Assume you are contacted because someone needs a programmer's services. To examine the issue, you meet with users from the client company, or you meet with a systems analyst who presents the project. Determining what you already know, the data provided as input, and what you hope to learn is the challenge of defining the problem, output the result. Eventually, you create a written contract that details the necessary input, processing, and output types among other things. This method is not straightforward. Plan the solution. The creation of a flowchart and the writing of pseudocode, or perhaps even both, are two popular methods of problem-solving planning. A flowchart is essentially a visual representation of a problem-solving process in steps. It consists of boxes and other symbols that represent actions along with arrows that show the program's direction. It is a roadmap for what and how your program will accomplish its goals. A common set of flowchart symbols has been created by the American National Standards Institute, ANSI. Figure 1 depicts the symbols and possible uses for them in a straightforward flowchart of a typical daily act preparing a letter for sending. Pseudocode is a non-standard language that resembles English and allows you to express your answer with greater accuracy than you can in plain English, but with less precision than is necessary when using a formal programming language. Pseudocode enables you to concentrate on the logic of the program without having to worry about the specific syntax of a particular programming language just yet. Pseudocode, however, cannot be run on a computer. Code the program. The next stage for a programmer is to write the program, which entails expressing their answer in a programming language. From the flowchart, pseudocode, or another tool, you will transform the logic into a programming language. As we've already mentioned, a programming language is a set of rules that gives the computer a method to be told what actions to take. There are numerous programming languages. Some examples are BASIC, COBOL, Pascal, Fortran, and C. Working with one or more of these may come up. Programming languages are far more precise even though they function somewhat grammatically like the English language. You must strictly adhere to the language's rules, its syntax for your program to function. The crucial thing to remember is that using the language correctly comes first. Then, using a terminal or personal computer, you must key in your coded program in a way that the computer can understand. A final word on this. To generate a file that includes the program, programmers typically use a text editor, which is fairly similar to a word processing tool. But if you're just starting off, you should probably write your computer code out first. Test the program. A well-designed software can supposedly be written right the first time, according to some experts. In fact, they claim that there are mathematical ways to demonstrate the accuracy of a program. The majority of programmers, however, are accustomed to the thought that their freshly built programs undoubtedly have a few defects because the world's flaws still exist. This initially seems disheartening because programmers are typically precise, cautious, detail-oriented, and proud of their work. Nevertheless, there are several possibilities to incorporate errors into programs, and you will likely discover several of them, just like those who came before you. You must eventually get ready to test the software on a computer after you've coded it. Desk checking, translating, and debugging are the 3 phases of this step. Document the program. Although it is a continuous and important process, you could be anxious to engage in more thrilling computer-related tasks, like many programmers are. A written full explanation of the programming cycle and specific information about the program constitutes documentation. The cause and nature of the issue, a narrative summary of the program, logic tools like flowcharts and pseudocode, descriptions of the data records, program listings, and testing findings are examples of typical program documentation resources. A crucial component of documentation is also believed to be comments within the program itself. As they code, many programmers keep notes. Program documentation may, in a broader sense, be a component of system documentation as a whole. The astute programmer keeps the program's documentation up to date as it is designed, developed, and tested. To aid in organizing program planning and to augment human memory, documentation is required. In order to interact with others who are interested in the software, particularly with other programmers who might be a part of a programming team, documentation is also essential. Additionally, since there is a lot of turnover in the computer sector, written documentation is required so that people who follow you can fix any flaws you overlooked or modify the program as needed.